Today we are going to be starting chapter 7. Yay! So today you're going to identify the parts of a polynomial, such as coefficients, variables, and constants. You're going to classify polynomials by number of terms and by degree. You're going to write a polynomial in standard form, and we're also going to add or subtract two polynomials. I think you guys are going to like this lesson. So 7-1, adding and subtracting polynomials. So the first thing we need to do is we need to understand what a polynomial is. So let's talk about that. So our first question, why does a constant have a degree of 0? So a monomial is a real number, a variable, or the product of a real number, and one or more variables with the whole number exponents. Okay, think about your PSR quizzes. You talked about that prefix mono. What does mono mean? Mono means one. So if I have a monomial, it's just one term. Okay, remember terms are broken up by plus or minus signs. Okay, so mono, 1. The degree of a monomial is the sum of the exponents of the variables of that monomial. Okay, it's the sum. So that means we are adding all of the exponents up in a monomial. So the variable in the monomial, 15x squared, has an exponent of 2. Therefore, our degree is 2. Okay, notice there's only one variable there, so we just take that exponent. Now, if we look at the next problem, 1/2 x to the 5th y squared, notice there's more than one variable. When there's more than one variable, we add all the exponents up. So we have 5 and we have 2. So 5 plus 2 is 7. So therefore, the degree of 1/2 x to the 5th y squared is 7. Okay, so then that brings us to a constant. A constant has no variable. Okay, so it's just a plain old number. Okay, any number to the 0 power is 1. Okay, remember, think about exponents. We just got done with those. Okay, so we can multiply a constant by x to the 0. Okay, because x to the 0 is just 1. And anything times 1 is just itself. So it doesn't change our problem. So really, we can take 7 and rewrite it as 7 times x to the 0. Again, remember, x to the 0 is 1, so we really just have 7 times 1, or 7. Therefore, the degree of a constant is 0, because our exponent is 0, so the degree of that is 0. Okay, big thing to just remember, constant is a plain old number, degree of 0. Okay, so now let's talk about how we name these polynomials. So a polynomial is a monomial, or the sum or difference of two or more monomials, which we call terms. Okay, the prefix here is poly. Poly means many. Okay, so it's many terms, more than one or more terms. Polynomials are named according to their degree. The degree of a polynomial is the greatest degree of any term. Okay, so polynomials, we have multiple terms. We look for each term, count up the degree of each one, and then we pick which term has the biggest degree. That is the overall degree of my polynomial. So here's some names. You want to make sure you copy this chart down into your notes. Okay, it's very important. Okay, so our first example is 7. Okay, that's a constant. We just talked about that. So remember, its degree is 0. Therefore, we call it a constant. Okay, next example is 4x. We look at the exponent. So what's the exponent on plain old x? You're right, it's just 1. So my degree is 1. We call this linear. Okay, think about linear equations. Y equals mx plus b. Okay, it is an exponent of 1. Okay, my next problem, 3x squared plus 2x plus 1. Okay, notice there's 3 terms, so we look at the degree of each term. Okay, so my degree here, the exponent is 2. The exponent here is 1. The exponent here, excuse me, is 0. Which one's the biggest? 2 is the biggest, so my degree is 2. This is what we call a quadratic. Okay, next example. I have one term. So remember, when we're finding the degree of one term, we add up all the exponents. So the x has an exponent of 2, the y has an exponent of 1. Add them up. What's 2 plus 1? I get 3. So my degree is 3. We call this a cubic. Okay, the next example, 4x squared y squared plus 5x minus 2y plus 6. Okay, lots of terms there, but again, we're just counting them up. We have 2 plus 2 gives me 4. Here's 1, here's 1. The biggest is 4, so it has a degree of 4. This book calls it a 4th degree. Some books will call that a quartic, okay, quartic sometimes, but this book calls it 4th degree. Anytime you have a polynomial with a degree greater than 3, we just call it fourth degree, fifth degree, and so on. Okay. I have seen that called a quartic before, and I might call it a quartic. In Algebra 1, you're not going to work with quartics. Actually, most algebra classes don't deal with them besides saying, okay, graph them in a graphing calculator and just tell me the zeros. But when did you have that vocab? Okay, so that's one way we can name a polynomial based on the degree. We can also name polynomials according to how many terms they have. Now this is super easy. You're just counting the number of terms. Okay, so my first example, 4x, there's only one term there. We call that a monomial. And notice the prefix mono. Okay, the next one, we have 1, 2 terms, so we call it a binomial. Okay, the prefix bi means 2. Then we have negative 5x squared y plus x squared plus x. 3 terms there, call it a trinomial. And finally, 4x squared y squared plus 5x minus 2y plus 6. 1, 2, 3, 4 terms, we just call it a polynomial. Once we hit 3, anytime you go 4 or above, we just call it a polynomial. Again, you want to make sure this chart is in your notes because that's very useful. Okay, again, poly means many. So the example this book gave us was 5x cubed minus 4. What do we call this? Well, let's start the degree. We have an exponent of 3, so that makes it cubic. And how many terms do we have? 1, 2, so we call it a binomial. Okay, a degree of 3 and 2 terms. So here, let's try a few. Please pause your computers and try these, and we'll go over them in just a second. Okay, we're naming each polynomial based on the degree and the number of terms. So sometimes it's easier to just count the terms first. This one has 1 term, so we call it a monomial. And then if I look at the degree, I have exponent of 1 and 2. 1 plus 2 gives me 3, so that is cubic. Okay, next one, 1, 2, 3 terms, so we call it a trinomial. Okay, and then we look at the degrees. Okay, I have an exponent of 1, so I got a total of 2. An exponent of 1, exponent of 1. Which one's the highest? The 2 is, so it is quadratic. Okay, so that is a quadratic trinomial. Okay, so now we're going to move on to standard form. So we want to know what the standard form of the polynomial 7x minus 5 minus x cubed plus 6x to the 4th minus 3x squared. So what is standard form? Standard form of a polynomial is the form of a polynomial in which the terms are written in descending order according to their degree. Okay, descending means go from greatest to least. Okay, so I'm looking for the one with the biggest exponent first. Okay, so looking at this, biggest exponent, 6x to the 4th. So 6x to the 4th is my first term. Okay, which one's next? Okay, so 4, 3 is next. So minus x cubed comes next. Okay, negative 3x squared is the next. Then a positive 7x and a negative 5. So standard form of this polynomial, 6x to the 4th minus x cubed minus 3x squared plus 7x minus 5. Okay, 4, 3, 2, 1, 0. Okay, notice that they are in order according to their exponents. Okay, your turn. Please pause the video and try these. Okay, so we're writing each polynomial in standard form. Letter A, 7 minus 3x squared plus 3x cubed plus 6x squared. This one has the biggest exponent, so negative 3x cubed is first, plus 6x squared, positive 7. All you got to do there. Letter B, 2y minus 3y minus 8y squared. This one's the biggest, so negative 8y squared plus 2y minus 3. Please make sure you're very careful and you keep the signs with the term. Okay, so now we can actually move on to the fun part, adding and subtracting. So how can we use the properties of operations to combine like terms and write the expression 4x plus 3x squared plus 2x plus x squared plus 5 in standard form? Now this looks complicated, but it's not. All this is combining like terms. So remember, like terms have the same variables and the same exponents. And we always write these in standard form. So I like to start by finding my biggest exponent first. Looks like this is my biggest exponent. Do I have anything else that is like that? Okay, remember, same exponent, same variable. I have an x squared right here. Remember, if it doesn't have a coefficient, it's always a 1. So I have 3x squared plus 1x squared. Gives me a total of 4x squared. Okay, standard form, so let's look at plain old x's. I have 4x, and I have a positive 2x. Gives me 6x. And finally, I do my plain old constants, so plus 5. Okay, and that's all there is to it. Your turn. Please pause the video and try these. Okay, so we're combining like terms and writing each expression in standard form. So start with the highest exponent. I see 4x squared, and here's a negative x squared. Remember, it's the same thing as a minus 1x squared. So 4 minus 1, 3x squared. Okay, then I'm looking at my next, so negative 3x, positive 3x. Oh, those just cancel. So my answer is just 3x squared. Okay, the next one, again, I'm looking for the biggest exponent. I have 7y cubed and 5y cubed. Gives me a total of 12y cubed. Okay, I don't see any squareds, so we're going to go to the plain old y's. So I have negative 3y minus 2y. Negative 3 minus 2, negative 5y. And finally, plain old constant, plus 7. Okay, I'm going to skip this slide because it's just doing the exact same thing. So let's look at this one. What is the sum of 4x squared plus 2x minus 3 and 3x squared plus 6? Okay, well, first question you should be asking yourself, what does sum mean? Sum means add. So I'm just going to take these two things and add them together. So I have 4x squared plus 2x minus 3 plus 3x squared plus 6. Okay, now you should be asking yourself, do those parentheses really do anything for this problem? Well, do I have anything outside to distribute? No. So the parentheses aren't really doing anything. So at this point, I can drop parentheses. And now looking at it, it's exactly the same as what we just did. So let's go ahead and combine our like terms. 4x squared plus 3x squared, 7x squared. 2x, well, I don't see any more x's, so plus 2x. And then my constants, negative 3, positive 6. Negative 3 plus 6 is a positive 3. There's your answer. Okay, again, please pause the video and try some. Okay, so we're simplifying and writing each answer in standard form. If it helps, you can absolutely rewrite it without the exponents, or without the parentheses. So 3x squared plus 2x plus a negative x plus 9. Combine like terms. I don't see any more x squared, so 3x squared. X's, 2x minus x is a positive 1x. And plain old numbers, positive 9. Okay, letter B, again, I'm just going to rewrite it without my parentheses. Combine like terms. Okay, I don't see any other x squared, so negative 2x squared. Looking at my x's, 5x and 3x gives me 8x. And then my constants, negative 7 plus 7, completely cancel. And there's your answer. All right, last thing we're going to look at is subtracting polynomials. Now, subtracting polynomials is almost identical to adding. The only thing that's different is we've got that negative. Now, you might just say, okay, I can just subtract in my head. And sometimes that works. However, sometimes we struggle with negatives. Okay, when I have minus and negative, sometimes we forget it's minus and negative, it turns into plus or positive. So to get rid of those silly mistakes, what I like to do is distribute. Okay, when I have minus, that's really just like a negative 1. So what I'm going to do is I'm going to distribute this negative 1 to everything in my second set of parentheses. Okay, this is going to allow me to just combine like terms. So I'm going to take my first set of parentheses and just copy them down. I don't have to do anything to this guy. He's already ready. So let's distribute the negative 1 now. Negative 1 times 3x squared gives me negative 3x squared. Negative 1 times 5x gives me negative 5x. And negative 1 times negative 8 gives me a positive 8. Once I have this, all it is an addition problem now. Okay, so let's look at our x squareds. I have 6x squared minus 3x squared gives me 3x squared. And my x's, 3x minus 5x, negative 2x. And finally, my constants. Negative 2 plus 8 gives me positive 6. So my answer is 3x squared minus 2x plus 6. Okay, your turn. Please pause the video and try these two. Okay, so again, remember it's a negative 1. I'm going to distribute that. So write down the first again. When I distribute, negative 1 times a negative x gives me a positive x. Negative 1 times 4 gives me negative 4. Now, all it is combining like terms. So I have 3x squared. 4x plus x gives me a positive 5x. And 2 minus 4 gives me a negative 2. And again, distribute that negative 1. Negative 5x minus 6. Negative 4x squared minus 6. Again, distribute. Okay, so I don't see any others, so negative 4x squared. Don't see any others, negative 5x. Negative 6 minus 6 gives me negative 12. Okay. These story problems actually are not very, actually we'll do one. An engineer is reviewing the layout of a solar farm. The solar farm shown has 4 small panels, 33 medium panels, and 32 large panels. What is the total area of the farm's solar panels? Okay, so we're going to look at more information. Total area of the large panels is 32x squared plus 384x. Total area of the small panels is 4x squared plus 24x. And the total area of the medium panels is 33x squared plus 276. How do I find total? You said add them up. You are absolutely correct. So all we need to do here is add these 3 panels. Okay, so if it's easier, you can write it all out. Okay, I'm going to extend my page a little bit. 32x squared plus 384x plus 4x squared plus 24x plus 33x squared plus 272x. Okay, and then literally just combine your like terms. Okay, so x squareds, I have 32 plus 4 gives me 36 plus 33. 36 plus 33 is 69 x squared. And then my plain old x's, I can't do this one in my head, so I'm going to pull out my calculator really quick. 384 plus 24 plus 272 gives me a total of 680x. And that's all you have to do for that problem. Okay, and the last one here. What expression models the difference between the total area of the large panels and the total area of the small panels? Difference means subtract. I'm going to take my large minus small. So my large is represented by 32x squared plus 384x. I want to subtract the small, 33x squared plus 272x. Okay, remember we just talked about when I have a minus, I'm going to distribute it. So I have 32x squared plus 384x minus 33x squared minus 272x. From here, you're just combining like terms. The 32x squared minus 33x squared gives me a negative 1x squared. And then we're going to do 384 minus 272 gives me 112x. Negative x squared plus 112x. And that's all it is. Okay, so pretty straightforward. Just remember the big thing is the subtraction. You got to remember to distribute. Okay, and watch those charts. Okay, those big things to pay attention to. Okay. So if you want to pause, you're more than welcome to. Okay, just a summary of everything we talked about. Homework tonight, you're doing page 265. You're going to do problems 15, 16, 19 through 35 odd, and number 36. As always, if you have any questions, please email me. Let me know what problems you have questions on, and I am more than happy to go through them. I hope you guys have a great day.